Let's take a look at how this new memory view works in our debug extension. So when we're debugging assembly code here, we have the memory viewer. It shows the addresses on the left and the values of the data at those addresses in hex here. And then if the values represent printable characters, then we also get to see the ASCII versions of those characters. Basically, if this was a string stored in memory, we would be able to read the contents of the string here. That's going to make sense. That'll be much more useful later when we have strings in our language. So how does this work? The main code is in this memory view provider.ts. We're basically adding a view into VS Code. We have a handy 2hex function. I'm not actually sure if I use this. Anyway, this will take a number and convert it to a string in base 16, and it will pad it up to whatever length we want with zeros here and put a 0x on the front of it. Just a little utility function. The main thing is this memory view provider class. So we're implementing the WebView view provider from VS Code. This lets us write some code to represent the view, and then we can supply the HTML and JavaScript that will actually display the view. So we're going to have our starting address of our memory that we're displaying. We have the actual data, which is an array of numbers. And we also have this change dwords. This is how we're going to animate when values change in memory. So if I start over here, and we scroll down and take a look at the stack, if I step, it's going to push data onto that stack. And you can see this was highlighted. There was a little animation where it sort of lit up and then faded. And then it stays highlighted here to show that this value changed since the last breakpoint that we hit, just like the Java debugger does, right? You may not pay that much attention to it, but that's a feature in the Java debugger. So now this is not highlighted anymore because it didn't change on that last step, but this value did. And here's the ASCII version of that same region of memory. So that's what our change dwords represents. We'll use it to do those animations and the highlighting. So resolve WebView view is called when our view is getting set up. We're going to enable scripts in our JavaScript, or basically enable scripts in our HTML, right? So we can include JavaScript. And then we add a message handler here. When our view receives a message, when our view sends the message, scroll off top, we're going to execute this code. So our view is HTML that can send message to this code, right? So the view is HTML and JavaScript. It can talk to the view class, which is not the same thing. It's really part of VS Code itself. And then we can also send messages from our VS Code view class back to the HTML view so that it can display change data, for example. So here we're listening for events coming from the view to us. So if the user scrolls off the top or bottom, we want to go load more memory. We'll go ahead and get the HTML, and then we're going to load data. So this is going to, this load data function is going to send a message to our debug adapter. So it's going to send a network message to the Java server that we have written, which will give us back a chunk of memory, and then we'll be able to display that memory. So we want to know our start address, whether we're refreshing memory that we already had or whether we're fetching new memory. So only when we're refreshing memory are we going to check for changes and then highlight where data changed. So if we're refreshing and there is data, then we'll set our bytes to fetch to that. Basically the data that we had, we're just going to go re-get all the data that we have. If we have scrolled off the top, our starting address in this function will be less than the address of the memory we've got right now. And so we're going to need to fetch the data from basically from that starting address to where our current memory block starts, right? So if we scrolled off the top of the memory we know about, we're going to fetch the data from our new starting point to the memory that we already have. Otherwise, if we scroll off the bottom, we're going to go get 512 new bytes. So now we're going to fetch that memory. We pass in the starting address that we want to use and how many bytes we're going to fetch. And then once we get the data back, we're going to update the view. So we're going to calculate our offset within the buffer that we know about. And if we're refreshing, we'll clear the change D words, and then we're going to go through the data and see wherever the data changed. We'll add that offset into our change D word set. Here we're looking at every byte, and then we have to do some math because we want the offsets of the D words that changed, right? So if 2 bytes in the same D word change, that should only get added to this set once. It really will be, the address of that D word will be the same, even though the bytes within it have different addresses. We also clear our data if we're refreshing. And then if our starting address is less than the address we were starting at before, we're going to update the start address for the whole view, and we'll concatenate the bytes onto the beginning of the data that we've got. Otherwise, we're going to basically put the new data into our data array at the right location. So we'll chop from 0 to the offset, we'll put the bytes in there, and then we'll also concatenate anything after that, right? So we could have a large region of data in our view, and we could be getting a chunk of that in the middle somewhere. And this will handle that. It will take the bytes before it and keep them, append the new data, and then append any data that we have that's after that area as well. And then as long as we've got the view, we're going to send a message to the view, update memory. We give it the address, the data, and the set of change D words. Actually, we turn it into an array at this point. Whenever we want to refresh the view, we're going to call that load data function and pass the refresh flag. If we've scrolled off the top, we're going to load the previous memory block. So we will load the data at our current address minus 128. If we went off the bottom, we're going to load data at the end of our current memory range, right? So the base address plus the length will be the end of the memory that we know about. And then fetch memory, this is how we send a request to the debug adapter. So we're going to go get the active debug session, and we're going to send a custom request read memory. And then this object matches the debug adapter protocol. So we're passing that memory reference, the offset, and the count that we will need to fill in this portion of the project. If we don't get anything back, we'll just return an empty array. Otherwise, we're going to convert the base 64 data that we got back from the debug adapter into a byte array, basically, or an array of numbers, I guess, because we're in JavaScript. When the debug session gets terminated, we'll reset all of our data. And then get HTML is where we actually give VS Code the HTML that it should display for the view. So here, we're going to figure out the path to our media folder memory view JS, and we're going to figure out the path to memory view CSS in our media folder. So those are these 2 files, which will actually control how the view looks. And then we're going to return our HTML, which will have a header that links to the CSS and includes our script, and starts out with a body that has a div that just says no data to display. And then our JavaScript will replace that if we actually have data. Our CSS is pretty basic. There's nothing too exciting going on here. Pre-formatted text in white. And here's our animation. So this I basically stole from the Java extension, Java debug extension. We have an animation that'll flash for 1 second. We have a background color. So basically, if we put this changed class on some of our data, it will be highlighted. It will briefly have a flash, so it gets highlighted, and then the highlight fades back, but it does still stay highlighted somewhat forever. And then here's the view that will actually display the data. So when we get a load event, we're going to go get our memory view element out of the document. We're going to add a listener to it for the scroll wheel. And basically, if we have scrolled within 5 pixels of the bottom, we will send the scroll off bottom message. And if we scroll all the way to the top, we will send the scroll off top message. So we can go get more data. Mark changed is just a convenience function that will wrap a string with a span that gives it this class changed. And then here's the real code that's going to render that memory view. So if we look at the memory view again, you can see we want the address and a colon. Then we want 8 bytes of data in hex with 2 spaces here, and then another 8, and then a space, and then we're going to have the ASCII version of the same data. So that's what this is building up. So we're checking our event. If it's an update memory event, then we go get our memory view. We're going to go get the address and bytes out of the data of that message. If there are no bytes, we'll use the no data to display as our inner HTML. We're going to create a new set from the change dwords so we know which dwords have been updated. We can highlight them. And then we're going to loop through our lines. Basically, line offset is going to count by 16, right? Bytes per row up here is 16. And we'll get the chunk of data that represents this line. And then we're going to build up an array for the hex and the ASCII for this line. Our dword offset will loop from 0 to 16, and we're going to go by 4s. So basically, we're going to get 4 dwords for each line. And then we'll slice the 4 bytes for this dword. We'll figure out if this dword has changed. So we calculate the address of this dword and see if it's in the set of changed dwords. We're going to turn our dword into hex. So we're going to map the numbers in the dword. There should be 4. For each of those, we will convert them to a string in hex, padded with zeros at the start. So we have a leading 0 if it's less than 16. And then we'll join those with spaces. So we're going to get, for each dword, we're going to get 4 hex 2-digit numbers. And then we'll add that to our hex list. And then we'll convert the dword to ASCII. So we're going to map that. Basically, if the value is between 32 and 126, it's a printable character. So if it is, we will use strings from charcode to turn it into that character. Otherwise, we're just going to display a period. And then we'll join those together, put that on the ASCII list. And then if our data ends before a complete row, we need to pad the end of the row with spaces. So here, we will go ahead and pad it out if we didn't have enough bytes to fill out the row. And then we're going to generate our label. So our address plus line offset is the address we're looking at on this line, convert it to hex, and then call our pad start function to put zeros on the front of it, make it a 4-digit number. And then we're going to push our actual row of text. So rows is our list of strings that we're going to turn into that are the actual HTML we're going to display. So 0x plus the label and a colon. Then we're going to take the first 2 dwords from our hex version of the data and join those with a space. Then we're going to have 2 spaces here. And then we're going to take the next 2 dwords and join them with a space. So we've got 8 bytes on the left and a bigger space, and then 8 more bytes, and then a space. And then we'll join together the ASCII characters. And that's one row of our display. And so then at the end, we join all those rows with new lines, and we replace the inner HTML. So this is really just a bunch of code to take an array of bytes as numbers and turn them into HTML so we can display them in the UI. So there's not a ton to this. Most of the time I spent building this was spent trying to figure out how to send messages back and forth between this code and the view, and wrestling with silly things like trying to get the alignment right in the view, getting the highlighting to work. It was real tedious stuff, but there's nothing too complicated going on here, right? We send a message, we get some bytes, we turn them into some HTML. Actually, one of the worst parts was trying to get the scrolling to work right. I could not get the scroll off the bottom event to work right until I changed it to fire whenever we got close to the bottom instead of hitting the bottom. VS Code was never actually hitting the bottom of the window for some reason. So yeah, just kind of fiddly stuff. But now we have a memory view, and that's going to be really helpful moving forward.